Welcome to the video lecture. In this video, we are going to learn about logistic regression, and we will be solving a problem using the concept of logistic regression. So logistic regression is a extension of linear regression, hence it is referred as logistic regression, and it is mainly used for classification problems. It is used for binary classification, and we will use a sigmoid function to produce a probability value between 0 and 1. For example, consider two classes, class 0 and class 1. And if the value of the logistic function, and there will be a threshold value there in the logistic function, and if the value of the logistic function is greater than the threshold value, then it belongs to class 1, otherwise it belongs to class 0. So this regression is used to predict the output of a categorical variable, and the outcome should be a categorical or discrete value. So it can be either yes or no, 0 or 1, or true or false. Hence it is used for binary classification. But instead of giving the exact value as 0 and 1, the logistic regression gives you the probabilistic value which lies between 0 and 1. So here in logistic regression, instead of fitting a regression line as we are used in linear regression, we are going to fit an S-shaped logistic function which is used to predict the maximum values 0 or 1. So this is the sigmoid function we are using in logistic regression, and this is the S-curve we are talking about. And the sigmoid function is defined as S of x is equal to 1 by 1 plus e power minus x, and it is also termed as a probability function. So this is a threshold value, and if the value lies greater than between threshold value and 1, and belongs to class 1, and if it is less than the threshold value, then it belongs to class 2. So these data points belongs to class 0 with a probability of 0.3, and these data points belong to class 1 with a probability of 0.8. So this is how your sigmoid function in logistic regression look like. So we are going to solve a problem based on logistic regression, and this is a data set which describes the hours of study of 5 different students, and based on the hours of study whether they are pass or fail. So we are going to use logistic regression as classifier to answer this following questions. That is, the first question is that we have to calculate the probability of pass percentage for the student who are studying 33 hours. So from the data set, you can come into a conclusion that 33 hours, if the student studied 33 hours, they will pass. So they are asking you the probability of the pass percentage for the student who studied 33 hours. And also they are giving you the probability percentage and ask you to calculate the hours of study that will make the student to pass the course with the given probability. So to solve this problem, we have to assume a model suggested by the optimizer for the given odds of passing the course. That is a logarithmic function, that is log of odds is equal to, and this is a formula to calculate the logarithmic function. So assume the model suggested this logarithmic function. So the next step is calculating the probability for 33 hours of study. So the given the probability function is 1 by 1 plus e power minus z, where this z represents the logarithmic function. There is log of odds which is described in your problem, and minus 64 plus 2 into hours of study. The hours of study is given here, and substitute the values, you will get the value of z. So substitute the value of z in the probability function to obtain the probability. Hence the probability percentage for the student who studied 33 hours to get pass is 88%. That is 0.88 is the probability value for the student to belongs to the class pass when he is studying 33 hours. So next question is, they are giving you the probability value and they are asking you the hours of study. How many hours that the students should study for getting this much pass percentage. So the probability is given. So hence the probability function is equal to 0.95, and then solving the equation will arrive at this solution, that is e power minus z is equal to 0.0526. Hence, to eliminate this e, we are going to take log on both sides to the base e. So log e to the base e, which cancels, which will becomes to 1, that is log e power x to the base e, which is equal to x. So based on this this statement will become minus z is equal to minus 2.94, which is the logarithmic value of these log 0.0526 to the base e. So this log to the base e value can be calculated in your scientific calculator using ln function. And so hence the z value can be calculated. Z is equal to 2.94. Here they are asking you the hours of study. So apply the value in the logarithmic odds function formula. So the logarithmic odd is equal to minus 64 plus 2 into hours of study. So apply the value of z so that you can calculate the hours of study. Hence the student should study 33.47 hours to pass the exam. Hence, a student should study at least 33.47 hours so that he will pass the exam with more than 95% probability. So, this is the way of calculating the probability of the particular data, whether it belongs to which class, using logistic regression. Thank you for watching the video.